Okay, now we're going to calculate our floor joist. So the first thing you're going to do is go to your drawing, and then you're going to have your drawing and the floor joist chart open at the same time. And what you're going to do is look for this distance from the outside of the wall to the center of the column. And my distance is 21 feet 2 inches. Then you come over to the chart and you look under 50 because 50 is the amount, 50 is the live load plus the dead load. Okay, you have the live load plus the dead load. So let's do 50. Okay, and then 16 inches on center is what we've been doing, what we talked about. And then you just go over to here and you see that the distance you can only do is 20 feet 5 inches. So at 16 inches on center, you cannot use a 2 by 14. So what you would do is you could go down to 12 inches spacing and then you can cover it. But we do not want to do that because the number of floor joists you would have to have in your house would be a lot more expensive, and um, it would make it so that it would also be time consuming to add that many floor joists. So what we're going to do is we're going to go to the engineered floor chart. Okay, we have engineered floor chart, and on the engineered floor chart, this is in our Schoology folder for basement, and it's called ENG floor joist. And you're going to look at this right here. So the first thing you're going to do is everything is going to be 16 inches on count, 16 inches on center. And the other thing you can circle is the 50, because the 50 is everything, the live load plus the dead load. And then you're going to look over to see we have to scale 21 feet 2 inches. So right here at 14, 16 inches on center, we can scale 22 feet 3 inches. So that's perfect. So we know that we need a 14 inch ENG floor joist 16OC. Okay, a couple of advantages to engineering floor joists. One, every single one of them is exactly the same. Conventional lumber is not always the same. So when you have engineering floor joists, your floor is much more even and flat because you don't have the floor joists that are different sizes. The other thing that you have is on these engineering floor joists is you can span a further distance with the same thickness, which is also an advantage, so that you can cover a larger span. So how do we put this into our drawing? So let's go to our CAD drawing. Let me open that up. Okay, so here's our CAD drawing. So the first thing you're going to do is draw a line. Okay, let's make sure we have this opened up. And we're going to click in here. We want to click on the line tool. And let's make sure everything's okay. Here's my line tool. I'm going to click from here to here. I'm just going to make an arrow. Okay. And then I'm going to take my alphabet tool under annotate, and I'm going to make a box like this. Okay, and the size we're going to go with 6, and we're going to type in E and G FJ floor joist 14 inches, and then we're going to click OK. So we're going to move that, So let's move that, modify, move. We're going to place it on that arrow. Okay, and then now you're going to get another text box for the bottom. Type 16 OC and make sure when you do that you have to change the font size every time. So let's do 6 and let's change that, and then let's move it. We're going to move this right here. Okay, so then once you have that, you're going to rotate. Now you have to rotate this arrow that you just made. Select all the pieces to it and the text. Enter from the endpoint, and you're going to type in 90. Okay, this arrow shows the direction of the joist. So then you're going to just move that. Hold the shift key down to select all the pieces. Let's try that again. Move. Move. Enter from the endpoint, and then you can put your arrow right here, and that shows the direction of your floor joist. And that's how you calculate and figure out what floor joist you need for your drawing.